I use it to help you out. Sorry? Go ahead. Go ahead. Okay. So I'm going to just kind of briefly go over it. I'm not going to go in detail because I still need to talk about one more thing for tomorrow, okay? When it's questions like these, please show the work. And I realized my choices were, you were actually outsmarting me. You were actually like, this can't be it. So you were eliminating the ones that couldn't be it, and some of you just guessed, which I'm like, hey, that means that you sort of understand what's happening here. You know what z-scores are telling us. Remember that z-scores tell you how many standard deviations above or below away you are from the mean. Okay, so here we go. This one was just a classic find a z-score. I gave you the mean and the standard deviation. You use the formula, you plug it in, it's 1.83. Okay. The second question, find the percent of data between these two z values, z-scores. And you know that the mean is 0 and the standard deviation is 1 if I give you z-scores. So you just plug that in, normal CDF, and it's 63.99%. This one threw some of you off, and this one so a lot of students pick 2 here. So you have to figure out how many tires would last, how many tires, right? The number lasting less than this. So you have to go watch this, negative 100,000 here, or negative 10,000 worked as well because you're in the negatives, but I went even lower. And I figured out the percentage, which is 2.28% of tires. But if you want the number, I don't turn that into a percent. I just leave it and I multiply it by the number of tires, people, games, whatever the case is. And so it's actually 34 tires are expected to last less than 57,600 kilometers. 4 was just basically, I give you the z-score, standard deviation, and mean. So you just have to use that other formula, right, to come up with the actual score, which is 77.5. This one is the one where a lot of you guessed. This one right here. So my bad. I should have made 2 answers that are very close. So if it's the top 8%, and I did graph this on your paper quite often if you got this wrong. So top 8% is at the top, right? On the right side when it comes to score, on the right side. So you want the 92%, right? So it's inverse norm 92% because you want everything to the left, Remember that song, right? You want to unremember it. I know you want to forget it, but anyways, 1.41 is the z-score. And so because it asks for a z-score, I go 0 and 1 into inverse norm, okay? So you got 1 mark if you used inverse norm. This one, you know what? I don't even want to spend too much time on it. But watch this, guys. When I ask you to use the graph, please use the graph. Don't use normal CDF or inverse norm. Just, I think the most common mistake here was not labeling it properly and perhaps forgetting percentage or something like that. But it wasn't too big of a deal for me. The graph was done well overall. Remember, you have to find the midpoints. Find the first 2, and then it should be a pattern. And then you type that into L1 and L2. But some of you, I think, are just typing it into L1 and L2, and you're thinking that's it. You need to actually go one variable stats, L1, comma, L2. You need to tell it, go and get those 2 columns. And the calculator then knows you're probably dealing with a frequency table. This is what you're supposed to get. And remember your units, sit-ups, number of, right, scores, points, whatever. When it's a word problem, there's probably a unit attached to it. And I gave you 3 marks for because you have to find this and this. So, right, considering that it had to be an L1, L2 scenario. I didn't graph it, sorry, I ran out of time. I just knew what it's supposed to look like. But what I did have here is your sit-ups, number of, and participants up here, number of. and I look for the correct scale. It has to be a consistent scale. You can't go 5 and then 15, right? That's a no. And also, some of you were kind of getting confused with this. If you're doing a histogram, listen carefully, you want to be using this to make your histogram, not some of you were just going from here to here to here. These are like the midpoints. That's when you want to do your polygon. Then you can use that. But if you're doing a histogram, use this. Okay, so if your X scale was off, but a lot of you did the zipper, so you are listening. And don't worry about that is it normally distributed? I just didn't count that because I hadn't talked about it yet. Okay, so some of you give it a try, which is, you know what? Always do that. Don't leave stuff blank. You will come across that in university and college. Give it a shot, right? You can't lose anything. Um, just just base it on what you do know, right? Okay, next page. Candy company. I think at least threw you off, right? The percentage of boxes weighing at least. So that means this or more. So some of you remember inequalities, right? So that was 336.5 to 10,000. And so that's the percentage that weigh more. And then I use that number here, multiply by 20,000. So it's approximately this many boxes. And I honored it. If you use this number here, you didn't lose marks again, right? Like you got it right. Next, we have a test score, 56 marks, less than 23 marks, right? You would go, right, negative 10,000 to 23, average and standard deviation. So it's 6.68% of students. Between these two, right, we have 78.71%, done very well, greater than 45. It was just done like that. So overall, you know what? I'm very pleased with stats. Is not easy, but I think you're showing potential. So we're good with that. So if only 10% of all students got a greater score than math than you, what is the score, right? So again, if you think of the bell curve, to the right is greater, right? So I'm giving you 10% are greater than you. So there's 90% to the left that are below you. So that's supposed to be 0.9. So a mark of this or this, I took both. And then the z-score for Russell, just calculate that. I can ask you explain what this means. You have to know it means that Russell, right? Russell is below the average by 0.83 of a standard deviation. Something along those lines. That's what that means. And remember, z-scores help us compare different students from different classes. The z-score kind of standardizes everything, right? So we can actually tell who did better and who did worse. And this one was an interesting question. I liked it. That's why I put it in there. So negative 10,000 to 157, because you want to know the percentage that did not make it, that were too short, 4.39%. That's in Winnipeg. And then the next one was in Brandon, right? 12.4% of adult females were too short to enlist. What minimum height must you have in Brandon? So you know the percentage to the left, right? Mean and standard deviation. So this is the minimum height one must have had to make it. And then in Winnipeg, right? We're talking Winnipeg, so this had to be taken from A, right? Not some of you were somehow using the 12.4, but it is actually in Winnipeg, so times 980, so approximately 43 women got that. And then the last one here, what you had to say is that when it comes, like, try to do this, talk about the standard deviation, right? Actually specifically say they both have the same standard deviation, which means both of them have the same consistency. Both classes score the same distance from the mean. You understand that? Because standard deviation calculates how far data is on average from the mean. So if you both have the same standard deviation, both scores are really close to that average, okay? Or are the same distance. We don't know if close or not because we don't have anything to compare to, but they are about the same distance. So the width of both should be the same. The width, right? Because the standard deviation determines the x scale or the width of the curve as well as the height, right? The bigger the standard deviation, the more spread apart, the tip is going to flatten. The smaller the standard deviation, the x scale reduces and it makes a taller curve, right? So that's kind of what's happening. And when it comes to the averages, Mr. Dirksen's class did better overall because the mean is higher, right? So something along those lines. And I apologize, the space wasn't the greatest. So if you hit almost all the things that I wanted to hear and see, I give you 1.5. If you like got it bang on, you got 2. And that's that. Okay, thank you guys. Put that away. All right. Let's see here. One more thing. You know that yellow review I gave you? That's for like the final review, the exam review. I will show you here. Just make sure you pay attention because there's kind of tons of stuff to know here, right? So if you go to classwork, I actually put it, it's going to stay at the top, but there's test review materials for this test, right? So there's a test review in the workbook. So if you grab your workbook, you just go towards the back of it. If you keep flipping, it says test review at the top. And so statistics unit test review, that's on page 18. And I put the key up there for you to look at, right? So I worked it all out with graphs and everything. So that should help you out there, okay? The next you can try is the exam review key. So that's actually the key to this one, to the big yellow booklet. If you click on that, I would like you to go all the way to the back almost. Right there at the back, that's when the stats review starts in this big yellow booklet. So if you want to go there and review that one, it's posted. The key is right there. Okay? I would say this. If you are like, don't spend too much time on the stuff we did today. Like the putting stuff in bins, there will be a question, but not like I would say focus on normal CDF and all of that, inverse norm, know how to figure out the percentages in between and all of that stuff. And just go through your notes. Yeah, Dion. Sure, go ahead. Another thing, I'm gonna give you test review AC. I'm not gonna take it and don't worry about it. I'm just gonna give you that. It has just quick questions, like it's just straight to the point where you will have to use normal CDF, inverse norm, all of that. And I will also post the key under test review materials. Under this, it'll show up somewhere when you go to classwork. Okay. And I will also make an executive decision, because what are they going to do? Fire me? Right? We're going to leave this for now. I still have to talk about, you can't see that because there is one thing that I needed to talk about, but there's very little math involved with this. It's all concepts, pretty much all concepts. What I will do is I will talk about this after the test. Next week, I'll spend like 20 minutes on it. And then I will expect you to know that for the final, like when we do the final, those final 2 tests, it'll be on there. And ACs and stuff like that, I will give you up until that point, right? So it's not like it's a lost cause. It's just I feel like you've seen and heard enough, and I don't want to overwhelm you. So when it shows up on the test, I will ask you to cross it. tomorrow. So that's the first thing I'm going to do. Remind me if I forget. We're going to cross off the 2 questions that deal with confidence intervals. Okay? You're welcome. What else? If you have your phones handy, I will just have this up there. I don't know if it's too small. It's probably too small, right? If it's a test checklist, it's not very like everything on it, but I'll do it in 2 parts. So if you want to take a quick snapshot there for the test checklist, that way you don't have to write it all down. So know how you do your graphs. Remember line plots? There will be line plots. Are you ready? And I'm going to give you that test review AC. And remember, if you want the bonus, I will call the video bonus question. That way you can, if you're interested, then you at least have a chance. Okay. Oh, I didn't hole punch this, so my bad.